Good morning, students. Today we are going to be doing work with polygons. So if you'll turn with me to 7.1, we're on page 225, and we're going to be working with polygons. So the first step is let's define polygon. Poly, that means many, and gon is a shape, many-sided shape. So polygon is a many-sided shape. There you go. That's what polygon is. So that's your definition. Now, what's a diagonal? Well, a diagonal is something that goes across a polygon. So a diagonal, that would be your diagonal. What if I had a shape like this? Well, I could have many diagonals. Well, this one has two diagonals, right? This is another diagonal. So there's two diagonals. Here, we've got a diagonal. There's a diagonal. There's a diagonal. There's a diagonal. So we've got many different diagonals in here. Okay. But what we're specifically looking for is how many triangles can you make in one. So there I've got two diagonals, and what it makes is 1, 2, 3. It makes 3 triangles, and you'll see why that matters later. So we're not going to be doing these diagonals all over the place, but that is a diagonal. It's just a line from one vertex to another. Line from one vertex to another. Line from one vertex to another inside a polygon. Inside a polygon. Okay? An equilateral polygon is polygon with all equal side lengths. Polygon with all equal side lengths, for example. There's one. There's an equilateral triangle. How about this? There's an equilateral quadrilateral. Yeah, it's pretty close. Let's pretend that's the same. So this is the same as this. Got that. Those are all the same size. So I'll just label it so that it becomes, they're all the same size. So that's an equilateral polygon. An equiangular polygon, what is that? Well, polygon with equal angles. So this is equal sides. This is equal angles. All equal angles. So again, let's take this one. We've got the same. So those are all 60. How about this one? We've got the same. So those are all the same. So those are all equal angular, right? And a regular polygon, well, that's a combination of equilateral and equiangular, is all the same sides and angles. It's polygon with all the same side lengths and same angles. So like a square, same side lengths and same angles. That would be a regular quadrilateral. Okay, now we're going to talk about the interior angles. Interior angles. So we've learned that when you have a triangle, the total interior angle sum equals 180 degrees. If you have one triangle, the interior angle sum equals 180. What if you have a regular rectangle. Interior angle sum equals, well, this one is actually 360. Remember, you have 90, 90, 90, 90, 90, 180, 270, 360. So the interior angle sum of a quadrilateral is 360 degrees. Now, one way to remember that actually is I can make two triangles out of this. So this triangle is 180 degrees, and this triangle is 180 degrees, so I have 360 degrees. So that's one way to remember it. Now, we've got a five-sided shape. 1, 2, 3, 4, 5. A five-sided shape. It does not have to be a regular polygon. If I have a five-sided shape, I can divide this up into three triangles. Three triangles. And so I have 180, 180, and 180. And 180 times 3 is 540. So the angle sum of this is 540 degrees. What if I had a six-sided shape? See this one? I got a six-sided shape. Let's check. There's one triangle, 2, 3. So I have 1, 2, 3, 4. I have 4 triangles. So a six-sided shape, 180 times 4, 720. So I don't know if you see a pattern, but this is going up by 180 each time. So there's actually a formula for finding out the interior angle. And the formula interior angle sum formula is the total number of sides minus 2 times 180. Interior angle sum formula, the total number of sides minus 2 equals 180. So let's check. So here we have a six-sided shape. So we have 6. So we have the total number of sides, which is 6, minus 2 times 180. 6 minus 2, 4 times 180. Come over here. 180 times 4. Look at that. 720. There you go. So that's the formula that you're going to use in order to find the interior angle sum. Or you may have the angle sum, and you might use this formula to find out how many sides something has. Okay? So keep that in mind. Now, so that's the interior angles. What about exterior angles? Here's a crazy thing. Well, let's look at it. Let's make it not crazy. Let's say I have a triangle. I have a triangle. I don't care what kind of triangle, just any old triangle. Let's say I pull these lines out just a little bit. Okay? So let's say this interior angle, let's say it's a regular triangle. So I've got 60, 60, and 60, right? Because 60 times 3, that's 180. So my interior angle, my interior angle sum equals 180 degrees. Now let's check my exterior. Now a line is 180 degrees, right? A straight line. If I had a straight line and I measured the angle, it would be 180 degrees if I had a straight line, right? And if I had a straight line and I cut it at a perpendicular line, this would be 90. This would be 90, right? It would be 180 degrees. So this line is 180. So if I subtract 60 from 180, this angle is 120. Same thing here. If I took 60 away from 180, I would get 120. If I took 60 away from 180, I would get 120. So my exterior angle sum for this triangle would be 120, 120, 120. 120 times 3 is 360 degrees. So that's how I get my exterior angle. Now let's go ahead and let's take a rectangle. So we have a quadrilateral. Let's extend this down. Let's just say this quadrilateral is 90 degrees on all sides. 90 degrees on all sides. So if this is 90, what's this angle right here? Well, that angle is also 90. Oh, let's go back one little bit and let's, what's our interior? Where's our interior angle sum? What is our interior angle sum for this quadrilateral? Well, it's 360. We learned, right, that a four-sided shape is 360 degrees. So let's see what our exterior angle sum is. So our exterior is the outside angles. So 90, so this one's 90 also. This is 90, so this is 90 also. And this is 90, so this is 90 also. So we have 1, 2, 3, 4. 90 times 4, we get 360. Hey, wait a second. 360. Well, that's weird. Our exterior angle sum for a triangle is 360. Our exterior angle sum for a quadrilateral is also 360. Wow. So, hey, Polygon exterior angles theorem. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360. So what it's saying is that no matter what kind of convex polygon you have, if I have a 10-sided shape, 1, 2, 3, 4, 5, 6, 7, 8. Well, that's an 8-sided shape. If I had an 8-sided shape, if I did this for an 8-sided shape, well, let's find out what our interior angle sum for an octagon, right? An 8-sided shape. So if I find out the interior angle, I go back here, I go in minus 2. So I have 8 sides. So I have 8 minus 2 is 6 times 180. So my angle sum is 1080. So my interior angle sum equals 1080. Now let's check. If this were a regular polygon, let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 angles. So that means that each inside is 135. So this is 135, 135, 135, like that, right? Each one of these is 135. Now, what are these outside numbers? Well, it's going to be 180 minus 135, so 45. So here's my angle here is 45 degrees, and then 45 degrees, and then 45 degrees, all the way around. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8. So I have 45 times 8. So my exterior angle sum for an 8-sided shape is, no way, it's the same as these. My exterior angle sum for an 8-sided shape is 360 degrees. Whoa. Exterior angle 360, exterior angle 360, exterior angle 360. So what that's telling us is that no matter what polygon we have, Our exterior angle sum is 360. Our interior angle is the number of sides minus 2 times 180. So our interior angle changes each time. Our exterior angle stays 360. Okay? So that's the lesson. Now let's do a couple of your homeworks. Find the sum of the measures of the interior. So we know that this is n minus 2 times 180 of the indicated convex polygon. So an octagon. Well, an octagon is 8. So I do 8 minus 2 times 180. So 6 times 180. 6 times 180 equals 1080. 1080. So there you go. Can you do it for 15, Don? Oh, of course you can, because it's just n minus 2 times 180. So 15 minus 2 times 180. There you go. Finish that off. Okay. But now, what if we wanted to go essentially in reverse? The sum of the measures of the interior angles, okay, interior angles, so I'm dealing with a changing number, of convex polygon is given. Classify the polygon by the number of sides. So I have to find the number of sides. My equation is the same. N minus 2 times 180. And up here, I was getting the answer. But down here, I'm given the answer, and that's my unknown. So it equals 900. So you know what I'm going to do first here is I'm going to actually divide by this 180. I'm going to get the 180 off of this side. So I divide by 180. So that cancels out, and I'm left with n minus 2 equals 900 divided by 180 is 5. So we get 5. Add 2 to both sides, and I get n equals 7. So if something has an interior angle sum of 900 degrees, I know it's got 7 sides. So go ahead and set these up just like this, and you'll be able to do it. All right, find the value of x. So in order to do that, I need to know what my interior angle sum is. So this is a 1, 2, 3, 4. So this is a 4-sided shape. So I know that my interior angle sum is 360 degrees. So I'm going to add up 65, 95, and 45. 5, 10, 15, 9, 10, 16, 20. So I have 205. So now I do 360 minus 205, and I get 155. So this angle should be 155. Now I'm going to double check by adding these 4, and I should get 360. So 65 plus 90, 65 plus 95 plus 155 plus 45. Sure enough, I get 360. All right. Now let's look at, is there only one? Well, we'll do, you'll have a worksheet too, so we'll do a little bit of the worksheet. So here I have to find out x. Now I'm dealing with the exterior angle sum, which, as we learned over here, the exterior angle sum always equals 360. So I have this 4x plus this 98 plus this x plus 162 equals 360. Because I know that every exterior angle of a convex polygon equals 360. So let's combine our like terms. I've got 5x and then 98 plus 162 plus 98, 260 plus 260 equals 360 minus 260 at 5x equals 100 divided by 5, and x equals 20. And that's what we're supposed to do, is find the value of x. X equals 20. All right, go ahead and complete that in your student journal, and then head on over and get the worksheet going. And that'll be your homework. It's the student journal and the worksheet. Ask me